Top voice was muted. uh, so we can wait a few minutes
Yes,
for
sir.
the
Yeah,
stream.
sure. Yeah.
Yeah. And we'll close when it is on 12. We'll close after around 25 minutes for
Okay.
today.
Okay. Yeah,
Okay.
sure.
And
Okay.
then tomorrow will be just Rhino and Grasshopper with no theoretical discussions like today.
Practical tutorials.
So they are coming. Yeah.
Yeah, they started joining.
Okay. Yeah, we can move forward, and
Yes.
if someone missed anything, just he can look on the YouTube, and tomorrow we can just revise what you had done and so on. I know it's too much, 5 hours, a lot of information and discussions. Yeah. Okay.
Okay, sir.
Uh, I'm sharing my screen now. Okay. Regarding Rhino, firstly, I you press Control N and start a newer document in meters. Okay, this is firstly. Secondly, starting working with Rhino, I have to say that Rhino is a CAD system, CAD CAM system, where you can design and extract 2D drawing, draw 2D drawing, export documents, export 3D models, and so on. And Rhino here in the bottom, you can see meters. And if you would like to change it, right click unit setting, and then you can select model units. I would like to start with meters. Okay, so now the model is meters. Meters mean I'm just talking in general, and tomorrow we'll do very specific exercises and so on. Okay, let's go. What the model is in meters, and this means when I start and draw the first point and then write 10, this means the black line is 10 meters, and then 20 and enter. This means the black line is stick to 20 meters, and whatever where I am in the viewboard, it is just the 20 meters, and I just following up and uh, clicking in a place to put the point. Okay, this is firstly. Secondly, yeah, so firstly was the units, meters. You can see it here down. Okay, secondly, if you just double clicked on one of these, you can maximize the viewboard. Double click again, it is minimized. So you have a top, front, right perspective. Double click, you maximize the perspective. And if you would like to go for the front view, you can double click again on the perspective and go for the front view and double click. Or you can go down here. There is perspective and there is top, front, right. Again, perspective. So you can double click on the tagging here and then maximize and minimize the viewports, or you can just maximize one of them and move along them from these bottom tabs. Okay, this is firstly. Second thing, working with Rhino means it is a CAD/CAM system, and this means as well, working on AutoCAD, you have snapping tools. Rhino has the same advanced snap tools, snap options as AutoCAD and beyond. This means if you are working, I'm talking generally now. If yeah, and just a minute. I'm sorry. Yeah, okay. Some family interruptions. um, sorry again. Working. If I'm going to write, just I'm drawing something like this. I can at the beginning I can pick the box and then I start with the first point and then I decide the dimension and then the second dimension and then the height, and this is how I can just do something into Rhino, and it is totally to scale. Okay, Rhino, as I mentioned, today we are just talking in general, and tomorrow will be specific and more details. So in general, if I am doing something, I should not just follow a specific steps. What I have to do, I just go for the box, and then I should look upside here, first corner, and so on. And then I select the option I would like to do it, and then start writing the dimensions. It is very easy. Okay, I can change the display mode for a shaded mode, for a rendered mode, and so on. And also, I can, if I change the display mode, I can change the layers. I can start a new layer, a right click, change the object layer, and make it red or something like this. I can select the other one, I can go for this layer and change object layer and so on. So I have one on the red and one on the green and one on the blue and so on. I can do transformations, very simple transformations using twist or any other component. Twist is a very basic, I know it's a very basic component, but if we go back in time, most of Dubai designs are developed on Twist. I remember the rotating tower and these kind of full designs. They were just mocking us, and they were just doing, in a 5 minutes. It's a 5 minute design time, nothing. But they are using a technology most of the people don't know about. I remember I was feeling just, what are you doing? Are you joking? This is very easy. But the world was just saying it's fascinating, it is very interesting, and so on, because they don't know how much time the architects spend for Dubai. It's nothing. You can do it very easily in Rhino. And the snapping is very advanced in Rhino. You can just right move, and when you right move, you will have the snapping. But the snapping tools as the AutoCAD system, you have to go for OSnap. Can you see grid snap, ortho, planar, OSnap, gumball, smart track, and so on? And just you select OSnap and you go down and select end, near, point, mid, center, intersection, perpendicular, and so on. When you stop above end, it's end point object snap. When you stop next to near, it is near to object snap. It is point object snap. It is mid object snap. What is mostly very advanced in the Rhino is that the NURBS thing. Rhino is mainly based on NURBS, but other softwares is mesh based. And this means I can go for display and just ask for. Okay, so now we can see the mesh edges and faces, but on Rhino it is totally a NURBS surface. And this is why Rhino is so advanced. Working with Rhino, I'm working with a mathematical equation, and all the other curves are just, all the other curves are just representation. These curves, I can select these curves. It is just for representation. You remember when you write a circle and then look for, it looks like a circle. And let's go for shapes. Yeah. If I write a circle like this, it is just a circle, very planar circle. Yeah. But if I just draw some lines, um, I, I'll just change some. I'll make it with no fill. Okay. And then if I went for the same circle and then added some lines, very simple lines, as this line, for example, this line, and then added other line in the other direction, in the U direction. Let's see, copy, and then I rotate like this. And told you this is a 3D object. You can look for as it a ball, a 3D object. These lines are just for presentation. These lines are just from the software to represent the mathematical equation. This is a ball, but without these lines, it is just a circle. Okay. So working with Rhino, this means working with a mathematical equation. So you can generate a Rhino object and export it for Revit or send it for Revit, and then you can select a surface, you can select a facade, you can select a roof, you can select a floor. But working with 3D Max or SketchUp, you can't enter probability with Revit or ArchiCAD and so on, because it is just a meshes, it is just thousands, millions, hundreds of panels, edges, vertices, and so on. It is not helpful at all because it is just a local drawing with no mathematical background, no mathematical equation, no advances or competences in its way of modeling and representing and so on. And also working with Rhino, we can have a very advanced surfaces. Like if I have these curves, if you remember your AutoCAD drawing, while working on AutoCAD, you had SP line. SP line, this means you have a point on the curve with a domestic transformation. When you move, you had a domestic transformation. But in Rhino, there is a control point curve where you had an international curve systems, international points, international control points, so you can design and develop a very smooth lines. And these very smooth lines can somehow implement it together and bring to life a surface, like very smooth surface in no time. And this smooth surface we can play with its degree. Because of this is made on Rhino. A Rhino is a nervous surface, and nervous surface means nervous equation. So if it is an equation, we can go inside the equation and change some of its parameters. So rather than just being a double curved surface, it can be a single curved surface, and it can be like a surface from a first degree. So it is segmental surface like this, or double curved like this, and so on. This segmental surface can take further and further. Like I can add a very futuristic, let's say very easily, I can array this into 12 by 12, and okay, so this is what we are going to do. I'll just draw a rectangular surface, almost rectangular, and I'll make few deformations. in that surface. Or I can just move it, play with the equation, making the surface, and then manipulate the surface itself. I can just select a few points from the surface equation and start manipulating the surface for more curved and advanced design. And then I can take this forward more and more. Okay, I can take these circles, very simple circles, and then make them as a group and do some general deformation. Tomorrow we'll be discussing more and more what I'm doing now. Now I'm just giving generally what capabilities, what options we have, and what can be done through Rhino. I'll firstly draw a basic surface beneath these kind of very beautiful circles. I'll make the surface exceed the circles somehow, and then I'll make a cage edit on a rectangle like this one. And the points will be 11 points. I'll manipulate it to the maximum. Okay, I'll take the surface, hide it, and play with the points. What I mean by play with the points, I mean I'll do deformations. Okay. There is two types of the cage edit. I choose the cage edit, not the cage, and then rectangular, and then we'll do the cage, and we'll select some points, and we'll start manipulating. You can see now I'm doing deformations, international deformations on the surface itself. I'm moving around. I can play with the surface like what I'm doing now. I can just maximize. Yes, I can select just 4 of them and maximize this in a point, and in other point I can select like 4 of them and like take them. Okay, and then I can easily flow along surface. Select this group that will be somehow here. You can see the deformation I made already here. I'll take a copy from the surface. I can just easily select and split and cut, and this is how I can have a manipulated, fine-tuned surface. So now I have a surface with the deformed paneling I just done. I can select all of these and make an offset for them and give it a distance and make it like real. Generating all of them now, generating the equations and working on the output. I'm not drawing everyone, but he is just generating them. They are too much. It is 12 by 12, and this means 144 circle. And now he just finished the 144 circle in less than 5 minutes. Any other software, can you imagine how many hours, not minutes, you will need to do such a thing? Let's do more transformations. If I had this one, and then I can not just a 2D basic element, but as well I can add a very basic, like something like this tube, and I will make it like very thin tube, and I'll array this 12 by 12. Okay, and then we'll array them Okay, okay, very, very good. I will make them group and then we'll go back for the surface. I'll do more further transformations and editing and advancing for the curvature and so on. I may take some of these points and then just tweak them. Just make life harder for the surface itself. Tomorrow we'll be manipulating and working together. Just bring your cup of coffee tomorrow, bring your laptop. If you don't have the software installed, you can just log into McNeil and download a trial version. And if your trial version is run, I believe you can have a solution. Okay, and then I'll do a flowing surface, select the base surface, and then select the target surface. Now I had the floated surfaces. I can show the surface edges or no. I can choose to show the surface isocurves also or no, and so on. And this is I can get some complex structures and vectors flow and so on. This representing the normals of the surface and how the sticks are manipulated through the surface structure. Very basic experimentations I'm doing now. There is no advances experimentations now, but maybe later on when we have enough time. I can just draw some few curves like these ones, and then take these ones and do rebuild for them. And then I can take some of these points. I will just select them, F10, and start selecting very random points. Yes. Then we'll do some transformations and sweep two rails, first rail, second rail, and cross sections. And this will generate, very, very interesting surface in no time. You can have very interesting applications and so on. And this very interesting application is just a Rhino surface. A Rhino surface means you can rebuild them, manipulate them. You can open the points and start tweaking the surface itself. Using Rhino easily, you can generate a lot of options, alternatives, and so on. I would like to share with you some of these. Just give me a minute. I'm in my laptop and all of you are seeing what I'm doing. Selected, yeah. This is some of my doing on Rhino. I'll share just some few. Easily you can design something from the future, like it's an experimental lab, experimental architectural materials lab in one of our very old school of architecture here in Cairo. And it is proposed to be floating like we are seeing now. I'll share later the Sketchfab link and so on. And there is still some other trials. This is one of the Hadid buildings that can be done like in no time on Rhino. This is one of her futuristic proposals. It is not constructed, but it is proposed. It is just an nervous surfaces, designs collected together, waiting for you to construct them in real. And some other ideas like making fur for a building, roof, and this structure is made in like 2 seconds. You can generate such a structure, such a truss structure in 2 seconds, as example. And this can be done like in 2 minutes. It's very, very easy to be done. Um, and some others. Rhino is very helpful while looking and thinking for the future. If you would like to, after graduation, if you would like to just go over vehicle design or jewelry design, as I mentioned before. This was a project I joined for designing a vehicle for a game. And I was just working on designing and manipulating and tweaking the surfaces on Rhino to design the future vehicle, how I imagine the floating and flying drones that can change our future and build our future. And this proposal is made like 12 years ago. Yeah, 12 years ago. Like a kid looking for the future. But now you don't need to just imagine, you can just build your future. And you can take this into reality by 3D printing techniques. Um, you can do some very, very interesting decoration elements and do 3D printing for it. This is all of this is my doing on Rhino, my projects. And this is a decorative element. It is very easily to be done on Rhino if you think like, very advanced way of thinking, how you can tweak the idea to its basic element and then aggregate the idea a final, very, very interesting and futuristic element. And others. There is a lot. Yeah, this one will be our last one for today to discuss on. This was a stadium, and I used Rhino for the whole design process, and yeah, and studying the structure and everything. Yeah, I was here. You can see the truss structure holding the glass facade, and the truss structure holding the ceiling, the seats, the stairs, taking everyone from outside to downstairs to the entrance, to the double court, double to here to the atrium, to everywhere. And you can not just design, but you can think while working. You can design by building and experimenting. You can design by experiencing what you are thinking of. It is not just based on your imagination, but it is more in your doing. And you can just build, look forward, and study and so on. There is still a lot we can share and discuss. Yeah, but I should save you time. Okay. So for now, I just finished. I'll stop sharing my screen. Yeah. So I believe now everyone should have a good understanding of what Rhino are capable of and what Grasshopper are capable of and what digital fabrication is. And in conclusion, we learn to use Rhino and Grasshopper not just to represent and design very advanced surfaces, but to be able to construct them as well into reality, to bring your dreams into reality. And I'm grateful and thankful for the professor and for Chandra for bringing me here and inviting me to meet you all. And I'm waiting for your comments and questions, not just now, but in the future on my email, WhatsApp, and LinkedIn, Facebook, and so on. And if there is any questions, I'm happy to receive them. If there is nothing, I'm happy to take a break.
Thank you, Professor Ahmad. It was a wonderful session. Really, you explained us how, from the inception to the building design, we can create with the help of Grasshopper, and difference between the different softwares. And anyway, today it was a theoretical session. Anyway, tomorrow it will be a technical, as you said. Tomorrow it will be going.
Yeah.
I still I agree with believe in yourself. That concept actually it applies to each and everyone, even for us and for all the students. So we can see the work what you have done. It's amazing, mind blowing. So we need, but the only is actually we're expecting you in live. That is, I think we have discussed with Architect Chandrasekhar. We planned you to bring down to India, but due to
Yeah.
Corona, we have just now it is like online session only. But in
It's
future,
my honor. It's my honor to visit
it's my
India.
pleasure also, sir. That is, we 100% sure that is we will get you back to India and we'll have a cup of coffee for sure. Apart
Yes.
from that, live session will be there. 100% a live session will be there, and I'm sure students will be quite cooperating. And I request now Architect Chandrasekhar to say a few words. And anyway, you're looking forward for tomorrow's session for the technical session. Yes, Chandrasekhar sir, please. Yeah.
Yes, sir. Thank you. Thank you. First of all, I would thank you, Mr. Hindustan School of Architecture, Mr. Suresh Bhaskar, sir. Why? Because he was believed my words, and then to participate of all students, and then I thank you very much, my good friend, Mr. Hazzav Ahmed, and you have a lot of work and right schedule. And yesterday night, also, be honestly, he was working at 3:30 at night. I mean, in Europe, I mean, Egypt time. He was working in the 3:30 his office.
Yes.
Then laterly,
Yeah.
just
I
three
was
hours.
attending a lecture in
Yeah,
US time. Yes.
yeah,
I just
just
sleep 2
3 hours
hours
only.
since
Yeah,
yesterday. Yes.
yeah, just 3 hours only. He can sleep. But definitely, he said, and he's honorable his words. And then he said, I was to participate. I told him, no, no, you can take a rest. And then, no problem. He can be joined with us. Okay, I feel really very happy about Azab. And then I must be happy about information how to digital fabrication made in modern materials and then applications and then how to choose your materials applications and etc. etc. Azab was explained very clearly and very short and clearly. By futurely in this course was established in our India, then detailedly we can explore with the students and then practically we can apply it. And one more thing, we have changing. Azab, you said router machine, no? I mean CNC router. We have it
Yeah.
in our. We have it already.
Wow.
We have purchased. Already we have
Wow.
purchased.
So when we visit India, we will be
Yeah,
able to
yeah, definitely.
construct a
Then we
real pavilion. Yeah, a real pavilion made of wood and a lot of small 3D printed objects. That is very interesting. We'll have an exciting workshop when you visit India.
Hindustan.
yeah.
Yeah,
It's yeah. I
Hindustan
think
School of
yeah.
Architecture.
Yes. So at the time you can come here. Definitely this there. You can take their CNC robot, and I mean that CNC rotor machine. Then you can go home with that CNC. It's no problem. We have it at present. Okay, but I have only one machine condition. But futurely we can purchase. I can purchase to later in more than two or three. And one more thing for the cooker robot. Already I told you, man. The digital fabrication for the cooker robot fabrication. So this is also very
Yeah,
difficult to understanding our students, the programming knowledge and etc. But definitely we can do it. Okay.
yeah,
Anyway,
we can manage
thank
it in the future. Yeah.
yeah. I hope. Thank you very much. Was a wonderful session. Uh, uh, like uh, transform our students. Anyone can talk with what is the opinion,
Yeah, questions, please.
questions, please, or any suggestions, please.
Yeah. After 5 hours. Is there anyone still have powers to share questions? I'm here for you.
Yes, yes. Students, anyone, please, if you have any doubt, please, you can clarify. You can ask question and the professor will clarify your doubts, please.
Yeah, I know. I
Maybe
remember when
tired.
I was a student. I remember. No. I'm not tired. I'm capable of working for 12 hours for a workshop.
Good,
No,
that's
it's fine.
great.
Yeah, because teaching is something so exciting for me, and especially reaching out to new community is something very important from my point of view, because knowledge is something we have to spread everywhere. And reaching out to Hindustan School of Architecture is something so exciting. I remember I never woke up early like this, but I'm early and so happy and so excited for what we are doing, and so excited for visiting the school in real after this
So
situation.
most welcome, sir. You have to
Yeah.
visit. It's our
Yeah.
honor to have you here, and I'm sure today the students would have learnt a lot, and tomorrow we'll continue with the same into. No
Yeah.
problem, sir. Okay, sir. Have a great day. Good day. Take care.
Thanks
Azab,
for your
See.
time, sir. Yeah.
Azab, please
Thanks
take
for your
rest.
welcome. See you tomorrow.
See you,
Thanks.
man.
I would
Thank
like
you.
to thank all the faculty members and students as well. Okay. So, see you tomorrow at 10 o'clock.
Yes.
Yeah.
Professor.
See you.
Yeah.
Yeah.
Okay, sir. Thank
Thank
you so
you.
much. Thanks.
Thank you, sir.
Bye,
Yeah.
sir.
Thanks for your time. Bye.
Bye.
Salam.
Assalamu alaikum.
Walaikum salam wa rahmatullahi wa barakatuh.
Alaikum salam.